Okay, we wait for the recording to be started. Okay, so we have started. Okay, so last week we cover on chapter 2 Fourier series part 1. Okay, last week also we should cover chapter 2 Fourier series part 2. However, I don't do that. Okay, if I do that, Fourier series part 2 should be a synchronous recorded. Why I didn't do that? Because in my opinion, we need to discuss this in class. So it will be flexible. Okay. And then you have learned from the last class, okay, which is the sinusoidal Fourier series effect of Fourier series characteristic. Okay. Now we will learn about Parseval relation and application of Fourier series in the circuit. Okay. Number 5, later on I will decide whether this second lecture will be asynchronous recorded or live, okay, because this one also need to discuss in class, but I will see later on. Okay, so we recall complex Fourier series. Okay, this is your complex Fourier series. Okay, it is this one is single-sided or double-sided? Anyone? You can respond in Google chat. Is this single-sided or double-sided? You guys can respond in Google chat. This question, is it double-sided or single-sided? Okay, good. So this is double-sided because, okay, exponential form, and then you have here, you have the positive part and you have the negative part. Okay, look carefully, you see here is negative n. Okay, here is also negative. Why? Because negative n. Then you see here, n from 1 until infinity. But if it's n equals to negative infinity, the question here will change. Okay, so you need to carefully see this range, this, and this. You need to see everything. Okay, if it's infinity means this will be simplified. This will be simplified only having one Cn. But how is it? You will see later on. Okay, so this is a triangular signal. Okay, triangular signal with amplitude of 2 and complete period of 20. So this is your T. So to calculate for frequency is F equals to 1 over T, which is 1 over 20. Where's my calculator? 1 over 20, which is 0.05 is the frequency. Okay. And then to calculate the omega, which is 2 pi F, so times 2, you get 0.1. So 0.1 pi, okay, for omega. So here, you see this, for example, the question, write the complex Fourier series of ST up to 3 harmonics. So when it means that 3 harmonic means N1, N2, N3, means there is until N3. But if it's asked for 4 harmonic, N until N4, something like that. And then the next step, okay, the next step, refer to Fourier coefficient table for the coefficient C0 and Cn. So you will given table, okay, you'll be given table and you need to solve it. Okay, so let me see. I showed it to the other section. I need to be fair, I need to show to you as well. Okay, wait for a while. I try to find. I need to find the final exam. Wait for a while. Wait, where is this thing? Assignment, this case, assignment, tutorial. Oh, okay. Forget I downloaded. Okay, let me show you guys. Okay. So let me show you guys. For example, this is the test, and this is the exam. So this is the exam. Okay. So you guys can actually, even though I will not sure I can give it or not, because actually, if I'm not mistaken, we are not to give the past exam. Student need to try to find it, to get it from somewhere. Okay, the examination. Okay, this is what I understand. Maybe I'm right or maybe I'm wrong. I'm not sure. Because some I have been briefed that this is not to be shared. Okay, never mind. Okay, but you can pause the screen. You can pause the screen because it's recorded. Okay, so I want to go to the last page. Okay, here. So you are given this mathematical formula. Okay, integration, trigonometry. You are given a Fourier series. You need to know how to use it, even although, yeah, it is given. Your life is made easier, so it is given. Means it will be like you just refer to the table. Last time we have to integrate. Last time me even last time when you like you a student, I need to perform integration. Okay, so our syllabus last time is a bit more difficult. Okay, so I hope this one made easier. That you only need to use the table. Okay, and then here exponential. Okay, you have a lot of this. Okay, the Fourier series. Okay, this one and this one. Okay, normally and standard in exam, final exam, you'll be given all the appendix. Okay, you'll be given all the appendix. In test, however, it is not given. Okay, in test, it is not given. Okay, you need to understand the hint. The hint. If it's given in the test, means that you need to use it. Most probably, it's not guaranteed. Most probably, you need to use it. But if it's not given in the test, you high chance you don't need to use the table. Okay, so jangan gatal-gatal, don't eagerly or ask lecturer, oh, where is the table? Where is the table? Okay, the table is not given because it's not used in the test. So you need to know the hint. You need to know the hint there. Okay. So maybe you make your life difficult if you actually try to solve for the table. Okay. So in the exam, the table is only given if it's needed. If not, you don't need to use it. Okay. So this is the hint. Okay. Compare directly the given graph with the one in table. This is the second step. Then you need to determine the x naught and your t naught. Okay. X naught is actually related with the amplitude. Later on, we'll see. Calculate the Cn values up to the required number of harmonic. For example, this one is third harmonic, so you should calculate C until C3, and then write the complex Fourier series for the whole signal up to the required number of harmonics. Okay. Okay. So this is the Fourier coefficient table. You can see, you can have a lot of type of waves, square waves, sawtooth, triangular waves. You have more other, and then you have this is your waveform. Okay, this is one. This is even or odd. This is even or odd. This one, square wave. This square wave, is it even or odd signal? Okay. Okay, it is odd signal. Why? Good. Okay, I can see you guys answering. Is odd signal why? This is positive and this is the negative part. So this one is even or odd? Number 3, is it odd or even? Okay. How about this one? Sawtooth, is it even or odd? Sawtooth, is it even or odd? Okay, good. Actually, sawtooth is neither, neither, because it doesn't show the even characteristic. It also didn't show the even characteristic, odd characteristic. You see, and then there is comment. There is 0 comment here. You see, triangular wave is odd, right? Is even, right? Even. So it's already put here. Comment for n even, Cn equals to 0. Okay. So you will have n1, n2, n3. Okay, and then you will see that this comment will help you to simplify your equation. Okay, but this one is even, this one is neither, this one is odd. Okay, then you have more wave here. Okay, full wave rectified, half wave rectified, square wave. I think you guys learn this. For example, this one, how to obtain this in digital, digital device, electronic device. Not sure. How you obtain this full wave rectified, half wave rectified. Okay. Then you have square wave, you have impulse train. Okay, a lot of type of wave. Okay, so now going back to the equation. Okay, going back to the question. So they want to solve us to solve this up to third harmonic. So means third harmonics mean n until 3. So this is the general equation. General equation of this exponential, combined exponential, exponential not combined. This one is depends. If you have 1 until infinity, your equation will be longer. The previous one, okay, the previous one that I showed. But if you have negative infinity and infinity, you have more compact equation. This is n not equals to 0. If n not equals to 0, where is n equals to 0? Anyone care to answer? Because here it mentioned that n not equal to 0. If where is n equals to 0? Anyone? You can respond in Google chat. Where is n equals to 0? Other than Chien Tong and Jawan, where is n equals to 0? Because this means we need to consider n to 0, but where is n equals to 0? Okay, so correct. N equals to 0 is actually C naught. Okay, means here. Okay, means here. So that's why in this equation, C naught is not C naught is not here. C naught and N naught is C naught. Okay, so now the equation is triangular wave. You can see this is X naught over 2. Okay, X naught is the amplitude. So your X naught is over 2. So your C naught is actually X naught over 2 means 2 divided by 2. So 2 divided by 2 here. Okay. And then you need to settle this one. I already tell just now. Okay. 20 milli. Okay. 20 milli is the T. And to have omega is actually 2 pi F. 1 over 20 milli. Then you get 100 pi. So if you guys don't know this, please refer to Google. Actually, this one is actually learned from secondary school. The relation between period, frequency, and omega. Okay, and then this is complex Fourier series given by the table. Okay, so you know that this is your C naught and this is your Cn. So because this is triangular wave, so this is the equation: negative 2x naught e jn omega t. So don't be afraid. Look like difficult, but it's not. Okay. You need to just substitute accordingly. So if it's n1, so this is 1. Okay, first harmonic. If it's second harmonic, n2 means pi 2 square means 4 pi. And this one is just 2. Okay, this one just subsequently whether it's first harmonic 1, second harmonic 2, 3 harmonics, and so on. Okay, looks difficult but not difficult. It's very quite direct, this thing. Okay, so I will change my screen to the touch screen. Okay, so you need to refer to your slide. You need to refer to your slide while I'm doing explaining the example. Okay, wait for what. You need to refer to slide number from 6, 7, and so on. Okay, I need to. Okay, where's my pen? Okay, so you can see, refer to question number, slide number 7. So you have your xt there. Okay, given xt. Okay, and then after substitution, you have 2 over 2. Okay, this one is actually what? X0, right? Over 2. Okay, and then you have from infinity. Okay, and you have from infinity until infinity. Okay, then n not equals to 0. And then you have negative 2. Then you substitute just 2 here. And then you have pi n square. Okay, and then you have e, j, n. Then you obtain that omega is actually what? Omega is actually 100. 100 pi. Okay, so 100 pi. Okay. Kecil when I maximize the slide, it looks smaller. Okay, so 100 pi. Okay. So now, so your C naught is actually 1. Okay. So okay, and then C1. Okay, you just settle accordingly. Then C1 equals to what? Negative 2 and 2 here. And then pi. And it's 1. Square. Okay. Then you get negative 4 pi square. The same goes for C3. Okay. You can see why we don't touch for like this. Okay. Why it says like up to 3 harmonics, but why we only settle on 1 until 3 only? Why there is no 2? Okay, can anyone answer me? Why is that? In this question, the solution showing only C1, C3, but why C2 is not showing? Why C2 is not calculated? You guys can respond at the Google audio, Google chat. If you get it wrong, no worries. It's good to make it wrong during now, not during the test. Why? Why here is only calculate C1, C3? Unite 0. Yes, correct. Because mention, you see here, triangular wave. This is wave. And mention here, for n even, Cn equals to 0. For n equals to 2, n equals to 2 is even, right? N equals to 4 is also even. So that's why, but the question is unti-third harmonic means you have 1, 2, 3. So what is even number? 2. So 2. That's why at 2, Cn equals to 0. That's why we don't bother to calculate for C2. Okay. That's why only C1 and C3. Okay. Thank you, Junaid. Okay. So we settle for that. Okay. Then I should put, wait, my screen becomes smaller like this. Okay, so now then your C3 is I just make it fast. C3 is -4 over 9 pi squared. Okay, and then you have the partner. Remember, because if it's complex exponential, so you have partner, which is the negative one. Okay. If you can see, the magnitude is always positive. Okay, the magnitude is always positive. Okay, because when we want to make amplitude spectrum, spectrum and phase spectrum, amplitude spectrum is usually always positive. Phase spectrum is different case. Okay, you can have negative and you can have odd. Okay, for the phase spectrum, but for amplitude it is always made positive. Okay, now the next one is that, okay, if you see the question, if you can see the question, okay, I make a new page. Okay, new. If you see the answer, the final answer, okay, please refer to the final answer. I try to make it maybe a bit slow. Okay, so okay, I finished writing. I hope I don't miss anything. Okay, so now this is our final answer. Okay, this is our final answer. Now my question is, where do you think this red come from? Where do you think this red part, this one, comes from? Okay, try to guess at Google Chat. Okay, before I reveal. Okay, where is actually this negative j pi come from? Initially, we don't have that, but now we have that. Initially, it should be, okay, negative signs. Okay, thank you. Welcome others. Where actually we obtain this exponent negative j pi? Initially, it wasn't there. Initially, our question should only consist of this part, summation of ejn 100 pi t and blah, 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 blah. But we don't have e negative j pi in the first place. Where do we actually have this e negative j pi? Other than Wacom? How on earth is that suddenly we have that thing? Other than Wacom? Because it's later on you need this skill in your answering the test whatsoever. You will using this a lot. This is actually conversion. Anyone? And other than Wacom? Why actually we suddenly have, it's not sudden, but why we have e negative j pi there? Okay, I cannot wait for all, but At least we can make effort, but it's okay. Now I explain. Okay. Remember, explain and put this in your mind and remember it. If you see here, this one is C1 is actually negative 4 over pi square. The same goes for C3 is negative 4, 9 over pi square, and so on. Okay, it's negative. Just like I told you guys, usually, and we make this usually, and of course, usually and always, this one amplitude spectrum is positive. It's always positive and usually is positive. So we need to convert this negative 4 over pi square, okay, into positive number. Otherwise, our equation will be like this, 1 minus 4 pi over 4 pi square and so on. The rest also for the same C3, negative. So then your amplitude will be not all positive. So we need to convert. How on earth that we going to convert that? Okay, so refer to your Euler's theorem. Okay, refer to your Euler's theorem. What is Euler's theorem stated? Can anyone check your slide? Okay, check your previous slide, because I want you to see, remember that previous is needed also to settle. So what is E cos plus what? What is here? Anyone? What is here? This is Euler formula. What is here? Euler formula. What is here? Before previous, okay, this one is actually, yes, this one is J theta. How about here? Is it theta? How about this here? This is theta, okay? How about here? What is here? How about here? Okay, here is sine theta. Okay. Now this is where the tricks come. Where the tricks come. Okay. Now you need to see. You see, you need to convert the negative one. If you see this question, okay, this one you need to practice a lot. Practice make perfect. You see here negative. You need to represent this negative in something else. Okay, that's why you learn Euler's theorem, negative. Okay, so what have you learned actually? What will result is that this will help you to convert. Okay, negative one. Okay, how you actually obtain negative one? You can try cos negative pi plus j sine negative pi. E j negative pi. Okay, so what is this? This is what? Cos negative pi is what? This is calculate in radian. Radian. What is it? Cos negative pi. Negative 1. How about this one? J sine negative pi is what? Okay, 0. Okay, so you can see negative 1 plus 0 is equal to negative 1. So that's why your negative 1 here can represent as E negative J pi. Okay, that's why now, oh, okay, can I make it a bit larger? Okay, never mind. Okay, that's why this one, okay, this one, this negative that you should have actually replaced by E negative J pi. Understand? Do you guys understand? Now where is this? Now you guys understand, right? Where is actually E negative J pi come from? Do you guys understand or not? Okay, understand? Only Abdul Rahman understand. The others, what are you doing? Understand or not? Okay, good. So you guys need to ensure practice make perfect. Again, practice make perfect. You have this equation. Euler's theorem, have a look. Cos theta sine theta equals to 1. Okay. You need to practice makes perfect. Cos theta plus j sine theta. Okay. You need to practice. Sometimes question maybe only one. If this one, how you going to represent in Euler's theorem? You need to modify what? Maybe here is pi over 2, here is pi over 2. Depends. And then let's say if it's -1, what is it? -1 means this one is -pi. Okay. So you need to always practice makes perfect. Means this will help you to convert because we want the amplitude spectrum always in positive. Okay, new page. Okay, new page. Now the next step is actually to convert to plot your signal. Okay, signal just nothing much there to be surprised of. Okay, so this one is make sure it is amplitude. Amplitude means modulus because it's always positive. Okay, then you have the first the first C0 is 1. Okay, the first is 1. Next is you have C1, which is at 100 pi. Second is at 300 pi. Another first harmonic is negative 100 pi. And this 300 pi. Okay. Next is C1 is actually what? Is 4 over pi square. 4 over pi square equals what? Anyone? Four over pi square is what? Can anyone answer? Put in your Google chat. Okay, it's 0.4. So a bit around like half, the 0.4. So this is your 4 over pi square. How about 4 over 9 pi square? How about this one? How much is it? Okay, so it is 0.04. Marking is getting smaller, so it's here. So you can see it's like getting smaller. Getting smaller. Okay, and then this is the partner counterpart. Okay, so you settle with that. Now you need to the phase spectrum now. You need to plot the phase spectrum now. So the phase spectrum you can see, okay, from the slide 7, you can see that again you still have 100 pi here, the same. Here is negative 100 pi. Here is negative 300 pi. Okay. Now to actually plot the phase, okay, if you can see all of them have negative j pi. Okay, all of them have e negative j pi because this one is the one that you have from the conversion. So all of them have negative j pi. So it's actually pi here, negative pi. So all of the phase is actually here. Okay, it's continue from the start. Okay, so e negative j pi. So this is your phase. Okay, and of course, 1 doesn't have phase, 0. Okay, 0 phase. The C0, because C0 is equals to 2 over 2 equals to 1. Doesn't have phase, only number, pure number. Okay. And then the same like what in the class, okay, the previous section just now. Sometimes you can get equation, sometimes you can get question given, they give you double-sided and they ask you to convert to single-sided. Or they can give you single-sided, they ask you to convert to double-sided. You need to know how. Okay, one of the way is actually Euler theorem. Okay, Euler theorem. And then usually, if this is your single double-sided, okay, this is your double-sided, this one. I'm not sure if the Google Meet, recording shown the my cursor. Oh, it doesn't show. Okay, let's say this one, the red circle. The red circle is double-sided. So if we want to convert to single-sided, okay, what is the difference in magnitude? Normally, the single-sided is double the size of this double-sided. Okay, normally the single-sided is double the size of the single-sided. If this is 4, for example, this one is 2. This one, if they say this one is 3, this one is 1.5. Something like that, okay? But how you convert in the equation, you need to know, okay? How to convert from, okay? One of the ways is actually you need to use your Euler's theorem, okay? Then we go to the next example. Okay, so write the complex Fourier series of Yt. Sketch a double-sided spectrum for this in anti-delta harmonics, means n equals to 3. Then we need to calculate our average power. Okay, average power. So this is what? This is a sawtooth formula, sawtooth signal. So sketch a double-sided and calculate. Okay, so you see from the table. Okay, I will share the table. Remind me, Chintong, if I don't share the table, I need to share. I need to share the appendix. Remind me if I don't. Where is the appendix just now? This one. Okay, remind me if I don't share to the class after tomorrow. If I don't share, please remind me. I need to share to the class the appendix. Okay, thank you, Ritong. Okay, where was I? Okay, so you can see this is actually sawtooth. Look like a tooth, sawtooth. So you can see it's sawtooth. This is complete period T0, and this is the amplitude X0. Okay, and then there is no comment. And you can see here, this is J, okay? So this is J. Now another trick comes, okay? Now you have this J, but your amplitude cannot have J. So you need to convert using Euler theorem as well to have this J convert into the exponential, okay? So you have this equation, okay? Let me snap this one first. Okay, so if you notice, we have J here. Okay, it's us until okay. What is the question just now? Sketch anti-third harmonics. Okay, whatever. Okay, anti-third harmonics. So anti-third harmonic means until n equals to 3. Okay. So first, make sure this one is until third harmonics. Okay. The partner. Okay. And then you see, your C1, you have J in terms of J. And then the same as well, you have in terms of J all the way, because the table provide you is actually the Cn is with J. So you see, this is how they convert it. Okay, this is also comes from the skill. That's why I repeatedly say that skill, you need to remember, practice makes perfect. So you have Ej theta equals to cos theta plus J sin theta, which actually resulted in J. Okay, so normally you can see from this equation, okay, I just teach you slowly, but later on you will be you expect you don't need this kind of slow things to do. You just actually pop. Okay, J is equal to Ej pi over 2, something like that. You means you already directly can know. Okay, if not, you still can calculate, no worry. Okay, so J. So how we get J is that this one, how to get J, this one need to be 0. Am I correct? This one need to be 0. This one need to be 1. So what is sine theta is actually, what theta actually result in 1? Is theta over 2, am I correct? This should be pi over 2, okay? Okay, so that's why when pi over 2, this become 1, this becomes 0, am I correct? And this one is pi over 2, okay? That's why you see here, 3 over pi, and this J is being replaced with this Ej pi over 2. Okay, so I hope you guys understand. That's why you have this. You see this one. Okay, and then purely positive. Okay, purely positive, because your amplitude phase spectrum should be in positive. Okay, I hope you guys understand. This is pretty straightforward. It's just that if you know, this one you need to always practice. How to convert. For this case, how to get J? How to get J? J is actually equals to E J pi over 2. The moment when you keep on doing practice, you will realize J is actually what? Negative 1 is actually what? Negative 1 is what? You will know negative 1 is E negative J pi. Okay? But you need to do practice. You cannot just avoid to memorize because we engineer, we have to actually to understand and to use. You are not to memorize everything. Some more the table is given, so what's the point of memorize? But you need to know how to use it. Okay, so you can see now, you can see this after you settle for that. Okay, after you settle for that, you will need to of course the final stage is to plot. Okay, so this one is double-sided, so you can see the trend going down. Okay, you can do at your own leisure. Okay, everyone, okay, do at your own leisure. Try to convert this to single-sided. What you have, even this one, try to convert. Try to convert this one to single-sided. If single-sided, it is a combined trigonometry. Okay. Okay. If it's single-sided, it need to be in combined trigonometry form. Okay. You cannot have this form. This form is a mixture of cos and sine. You cannot have this form. Single-sided should be consist of combined trigonometry form. Okay. So from here to here or to here to here. Okay. So now you have the double-sided. Later on, you challenge yourself. Try to produce the single-sided. What does it look like? Okay, single-sided for both amplitude and the phase. Okay, you can try at your home at your own leisure time. Okay, the next. So far, you have question? I think I'm a bit quite fast. You guys understand? Is it okay? If you okay, just say okay in the Google chat. Okay, I'm worried I'm a bit fast because section 3 I explain a bit more longer, but the content is there. Okay, the content is there. Is it okay? If you guys okay, I will proceed. Okay, 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 good. Actually, I plan for this section 3 and section 4 to be combined in one lecture, but I know it's not possible because students have their own schedule, I know. But one of the reasons why I want to combine, okay, of course, it will make my life a bit easier to give just one lecture. But the other advantage is that both of you will have the same lecture. Both of you will have the same lecture. But since that we have separate section, it's normal for me. Sometimes I speak extra for your section and sometimes I speak less for the other section. Or sometimes I speak less for your section, I speak extra for the other section. So this is a bit disadvantage. But later on, let me see. For now, I need student to always active at e-learning. So later on, maybe YouTube video will be public, but later on, this one later on, okay? But now I need you guys to be active at e-learning, okay? Student also need to be active in learning because it's measured, the usage of e-learning, okay? So this is the disadvantage, if possible, actually to combine section 3 and 4, but I know it's not possible. But this disadvantage that I may left some information. I mean, some section may have more, some section may have less. But but the main content is there, okay? You don't worry, just the main content is there, just extra. Sometimes you may lose some extra, okay? Or sometimes you can gain some extra, okay? So here, okay, this is the average power, okay? Where is the next question is they ask to calculate the average power. You see the average power. So you need to calculate the average power. Okay. So now my question is that since you already study circuit theory, I think circuit theory teach this, and if you forget, oh my god. Okay, never mind. Okay, so why My question is that why we have square root of 2 here? Okay, anyone? Why we have square root of 2? Because the standard equation, I think even you study this in secondary, power is equals to V square over R. But why here we have square root of 2 here? Anyone? You can respond at Google Chat. Why we have square root of 2 there? Just guess, just guess. Because it's important. Only it's important for you to know what you didn't know, or for you to know what you know. The most important one is to know what you didn't know. So why we actually have square root of 2 here? Anyone? Why we have square root of 2 there? Why we don't just use V square? Why we need to put square root of 2 there? Anyone want to try? Or maybe it's a bit difficult to explain in Google Audio. Maybe Google Chat, you can use Google Audio. Why? Why we have this? Why we have square root of 2 here? Why is just not direct V square? Anyone? Circuit theory, this is circuit theory. Okay. I think maybe, okay. Okay, like this. Normally, okay, in decibel, in the dB value, okay, in dB, this is, I just try to start from the beginning. Normally, is 0 dB is maximum. 0 dB is maximum. For example, to get the dB is 10 log. Okay, the formula from linear to dB conversion, to 10 log and linear. For example, 100%, 100% which is 1. 100% is 1, 50% is 0.5. So 10 log 1 is what? 10 log 1 is what? 10 log 1 is what? Can you guess? 10 log 1 is what? Okay. 10 log 1 is 0. Okay. And then how about we go to the half of the value, which is 0.5. So what is the value? Ten log 0.5. Okay. So 10 log 0.5 is around -3. Okay. Around. But we run up, it become -3. Okay. So this is actually the value of decibel, the value in log from 100%, which is 0 dB, until -3 dB, which is 50%. Okay. You learn also, actually, you learn also about VRMS. Okay, what is the VRMS? Do you know what is the equation for VRMS? VRMS, actually you guys can Google. VRMS is equals to what? VRMS. VRMS. I think the other section also blur. I don't know. Maybe this is your first class in the. I'm not sure. Okay. VRMS. Even the other section also a bit blur when I asked last time. When I asked just now, the previous section. Okay. So you can actually go to ways. Okay. 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 You can actually see VRMS. What is the equation to get? Okay, Chintong, yes. VRMS, yes. Square root of 2. Okay. So you guys can actually see here. Okay. So good, Chintong, thank you. So VRMS, you see VRMS is usually V peak over square root of 2. Or VRMS also can be V peak to peak. Why we need to divide by 2? Because V peak to peak is double. So that's why we need to divide by 2. Okay. So here you see this is V peak to peak. 1 over square root of 2. Okay. So that's why you can see here. And from this signal, from this, you know, actually, the entire signal is not always at the peak. It's not always at the peak. It's not always maximum, you know. So you need some value to like average it. Okay, like average the value. It means it need to consider all of the other condition. Okay, so that's why we need to use V over 2. This is like VRMS, right? Okay. Sorry, apa yang saya tulis ni? 2. Okay. So P average, okay, equals to V peak over square root of 2 and square root, and then R1. Why we use R1? Because it is normalized by 1. Okay. Later on you will see why we normalize by 1. Let's say I want to normalize something. I want to normalize something by 50 ohm. Means 100 ohm. To be normalized with 50 ohm means 100 ohm divided by 50 ohm. Then you will have 2 ohm. 2 ohm normalized. 2 ohm normalized. Normalization with 50 ohm. Okay. If you have 100 ohm, normalized with 100 ohm means 100 ohm divided by 100 ohm. Then you have 1 ohm, which is normalized 1 ohm. 1 ohm, which is normalized with 100 ohm. So this one is normalized with 1 ohm. Okay. So that's why P average, this is already explained, and this one is R1 normalized. Okay. Then the next step is actually for you to sketch the signal. Okay, for you to sketch the signal. Okay, average power, complex exponential. Okay, so you can see this is of course the highest value, and this is your average signal, average equation. Average power, complex exponential. If you can see again, you need to be very careful. This one is from n1 equals to infinity. And this one is from negative infinity until negative 1. Means this one is at the positive side because the lower limit is 1 until infinity. And this one is at negative side because the upper limit is negative 1 and lower limit is negative infinity. This is the complete form. Okay. Then if you want to make it simplified, because the amplitude is always the same, right? Always the same for both sides. So you just simplify this times by 2, and then remember n equals 1 until infinity. And this the same. This is Cn square, okay? This one is Cn square. So this is the simplification, okay? I think the logic is there. You can understand. Okay, and appendix, let me see if appendix is actually show to you how to calculate average power. Otherwise, you need to remember anything that is inside the appendix. You don't have to remember average power. Is it asked or not? Is it mentioned in the appendix or not? Average power. See, there is a transformation here, amplitude transformation. Okay, this one maybe later chapter, maybe not this. So you see, this is exponential form of Fourier series. They show the general equation, and then you need to change accordingly. This is just standard. Then this one you customize it to according to what the waveform that you see. Power, where is the power? Duality, time reversal, impulse. Oh, if it's not given, you need to memorize. Huh? Oh, is it? No, this is filters, pen pass, pen stop. Oh, I think it's not given. I think it's not given. You can see later on, this is the complete appendix. I will provide later on. I think it's not given. Okay. So, but if it's not given, also if you see, it's not that difficult. Okay. It's not difficult because it's just square everything. Okay, square everything. And this one always modulus. You see, even though it is modulus here, and then square there, because means when you square, everything is always positive. So this is modulus. Okay. And then this is the Parseval theorem. Okay, Parseval theorem, a periodic signal carries a periodic Parseval theorem. So it's about periodic. So you need to know periodic Fourier series. Okay. Maybe in later chapter you will learn about Fourier transfer. Fourier transfer is about Fourier transform to transform lah. Okay. So about Fourier series, you learn about this periodic. So Parseval theorem, periodic signal carries a fixed finite average power level per signal. The power is normalized to 1 ohm. You see here? For Parseval theorem, the power is normalized to 1 ohm. So that's why we have R equals to 1 there. Okay, R equals to 1 there. And then Parseval theorem states that the average power of the periodic signal is the sum of the average power in its harmonic components. Okay, the average power of the periodic signal is the sum of the average power in its harmonic components. You can see this is your average power, and this is the sum of the average power in its harmonic component. Harmonic is like N1, N2, N3. Okay, if given 5 harmonics, so N90 is to 5. So this is the average power formula, and this is you simplified. Okay, simplified. Cn is the average power in nth harmonic component of Vt. Okay, your C naught can be 0. Depends. Your C naught can be 0 because if C naught is actually the value with independent of phase. This is a DC. It's DC. We don't have phase. That's why n equals to 0, and you see there is no phase. DC value. Okay. Wait for what? Sorry. Okay. Where were we? Okay. So you can see this is the graph. Okay, for the Cn amplitude. Cn modulus amplitude always positive because you see this is modulus. So C3 as your C naught. So you use C3. And then you use this to consider both sides. You just times by 2. Okay. Then the magnitude is 3 over pi. Just accordingly substitute. Then you have the power average in watt. Remember to what to write whether it's milliwatt, microwatt, or watt. Remember, this one is sometimes a silly mistake or careless. Okay, so this one this one will not be covered in this lecture. I will cover later on. Okay, I will cover later on. Oh, I finished a bit fast for this class. Okay, so now go to your e-learning. Okay, go to your e-learning. Okay, you can go to your e-learning while I'm doing something. Okay, while I'm doing the appendix. Where is the e-learning? Okay, go to your e-learning. Okay, go to your e-learning. Right here, what have you learned for today? Okay, while I'm preparing the appendix. Please write. I will share this recorded lecture. If 27 people and above already respond feedback here, means 80%. Just type what you learn. Okay, I stop recording. Okay, please go to your e-learning. Just